Eric Burgess here, and we are tasked with verifying that the quantity secant theta plus cosecant theta times cosine theta minus sine theta is equal to cotangent theta minus tangent theta. So this one seems to have a pretty clear first step. We're going to start with the left-hand side. And in fact, let's go just straight for the proof again, and maybe we won't even need to do an exploration area. And immediately looking at this, secant theta, right, that's 1 over cosine, and this is 1 over sine. So they're going to simplify with some of this when we multiply out. So we're going to get some mixed bag stuff here. So our first step is, let's go ahead and use reciprocal identities, identities. That'll be our justification. And we're going to get 1 over cosine theta plus 1 over sine theta. I don't know why I'm writing so small. I'll write bigger in the next steps. Times cosine theta minus sine theta is equal to cotangent theta minus tangent theta. So this is what we're trying to show, and the name of the game is touching only the left-hand side. Can we get it to be the same as the right-hand side? So let's go ahead, and our next step will be distribute. So let's write that in. Distribute. I'll just write dist for distribute. So 1 times cosine theta is going to simplify to 1. And then cosine theta times sine theta, this is going to be negative sine theta over cosine theta. I'm going to leave them in terms of sines and cosines. You could write tangent theta if you really want to. Then we're going to get plus, and then this is going to be cosine theta times sine theta when we multiply these two. And then we're going to get, when we multiply these out, we're going to get minus, and then sine theta will cancel, and we'll get 1. And I can already see the light at the end of the tunnel. Cotangent theta minus tangent theta. Okay, the 1s will simplify and we'll combine like terms. So combine like terms and tangent and cotangent definitions. That's our justification for this step here. All right, so the 1 and the 1 will simplify. We're left with a negative tangent theta and a positive cotangent theta. And this is equal to cotangent theta minus tangent theta. And now a lot of you might stop here. Your professor might be cool with you stopping here. But just to be safe, we can also claim commutivity. So remember, associativity just means that the order that we associate A times B times C, or whatever, we'll put the B out here. It's saying that this order doesn't matter. We could group it like this, or we could group it like A times C times B. We're associating them different. Commutivity states that we can exchange their place. So that A times C times B, we were claiming that this was equal to that. We're claiming that ACB, if we're claiming commutivity, is BCA. And we know that since we're dealing with these trig functions, this is one of the things we're allowed to claim commutivity. But that's what we're doing here. So some teachers might care about this. At this level, I don't know. So I'm including it here just to be safe. I think most teachers would, at this level, would be totally fine with you just sort of doing things without stating it like we're doing here. But there's always that one teacher who wants to see it all written out. And there's nothing wrong with being rigorous. And so we could see that this indeed is the case. This mess over here is equal to this mess over there. So there we go. We've got ourselves a small proof of it. If you have any questions about this, let me know. Subscribe and hit that bell icon for future videos. And we'll catch you in the next problem.